everyone, and welcome to the ALCHEMYX YouTube channel.
Hey! You wanna learn some science? Come on and join the fun today. I've never seen you curious anymore. I'll open up your door. Let's mix and match the world. Be awesome to be buddies. Sharing knowledge. Let's push it to new terrain. Do you wanna learn some science? Let us explore and play.
Bright, fun, and divine.
Okay, fine.
Today we'll be discussing the periodic table, a fundamental chart in the world of chemistry. But before we dive in, let me introduce myself. Hi, I am Crystal Ancandubo, and now let's get started. Are you familiar with the connection between the periodic table and the general chemistry? The periodic table is the cornerstone of general chemistry. It's like a cheat sheet for chemists, organizing elements based on their properties. These help chemists predict how elements will react, what kinds of bonds they will form, and even how to write formulas and balance equations. But before we delve deeper into the periodic table itself, let's first explore the life and work of its creator, the father of periodic table, Dimitri Mendeleev.
Hi, my name is Jadis Danazake.
And I'm Manchester Rivera.
Dimitri Mendeleev, the inventor of the periodic table, was born in Tagos, a small Siberian town. He was the last of 14 surviving children of Ivan Pavlovich Mendeleev, a teacher at the local gymnasium, and Maria Dmitrievna Kordonova. Dimitri Mendeleev faced family challenges as his father became blind in the year of his birth and died in 1847. But to support the family, his mother turned to operating a small glass factory owned by her family in a nearby town. However, the factory burned down in December 1848, and her mother took him to St. Petersburg, where he enrolled in the main pedagogical institute. His mother died soon after, and Dimitri Mendeleev graduated in 1855.
After graduating, Dimitri Mendeleev continued his study in St. Petersburg, earning a master's degree and a doctorate. He then furthered his education in Germany, where he interacted with prominent chemists but opted for independent research. He returned to St. Petersburg and became a professor at prestigious universities. Throughout the 1860s, his research focused on various areas such as liquids and spectroscopy. In 1869, Mendeleev published his groundbreaking work of the periodic table, organizing elements based on their atomic weights and predictive properties of undiscovered elements. His system, known as the periodic law, revolutionized chemistry.
The invention of the periodic table remains the cornerstone of chemistry, providing a fundamental framework for understanding elements and their interactions. Dimitri Mendeleev's story exemplifies dedication, resilience, and the pursuit of knowledge, inspiring generations of scientists.
Let's take a closer look at this amazing chart. At first, you might think that it looks complex, but the periodic table of elements isn't as confusing as it appears. In this video, we will break down into small pieces. We will learn how the elements are organized, explore the different groups and their properties, and finally, uncover the wealth of information hidden within each element square. So, grab your favorite pen and get ready to unlock the secrets of periodic table.
The periodic table is like a giant grid. Its elements are arranged in 7 horizontal rows, known as periods or series, and 18 vertical columns, known as groups or families because of their similar chemical behavior. The chemical behavior of atoms is determined by their electron configuration.
In addition to what Microbe stated, remember that Mendeleev arranged the periodic table so that elements with the most similar properties were placed in the same group.
That's correct, and actually, it is their similarities in their chemical properties that cause them to be placed in the same group. Now, let's dive into the groups.
If you are all confused, a group is the vertical column of the periodic table.
For example, Group 1A, also known as alkali metals.
All of the 1A elements have one valence electron, so this is what causes these elements to react in the same ways as the other members of the family. Elements in 1A are all very reactive and form compounds in the same ratios with similar properties to the other elements.
Group 2A, or the so-called alkaline earth metals. So, the alkaline earth metal is any of the 6 chemical elements that comprise Group 2A of the periodic table. The elements are beryllium, magnesium, calcium, strontium, barium, and radium. They all have similarities in electron configuration, as these elements all have 2 valence electrons.
In the middle part, you can see the transition metals. Transition metals occupy the D block, or groups 3 to 12, in the periodic table. It has unpaired d electrons in their atoms even in their stable cations, or positively charged ions. This electron configuration allows them to form multiple oxidation states, number of electrons lost or gained, and colorful compounds. And examples of it are scandium, titanium, vanadium, chromium, manganese, iron, nickel, copper, and zinc.
At the bottom part of the periodic table, you can see 2 separate rows. That is the inner transition metal. They generally belong to group 3 in the periodic table but are mentioned separately as the F block elements. These F block elements are known as inner transition elements.
And there are 2 series of inner transition elements, the lanthanide series and the actinide series. If the last electron enters the 4f orbital, it is said to be the lanthanide series. If the last electron enters the 5f orbital, it is said to be an actinide series.
Let's proceed with the post-transition metals. These elements occupy a kind of ground between the transition metals on their left and the metalloids or nonmetals on their right. They include group 13 to 16, elements like aluminum, tin, and lead. While they are classified as metals, they tend to be softer and less strong than true transition metals as their melting points are generally lower.
And as for the fascinating group that bridge the gap between metals and non-metals, the so-called metalloids. Metalloids, as I mentioned, are chemical elements whose physical and chemical properties fall between the metal and non-metal categories. They lie along the diagonal line from boron and polonium on the periodic table.
It is important to recognize a couple of other important groups on the periodic table by their group names. Located on the right side of the periodic table, it includes fluorine, chlorine, bromine, iodine, and astatine. That is referred to as Group 7A, Group 17, or halogens. This group contains very reactive non-metal elements, and most halogens are electron-hungry.
So, the noble gases, which are in group 8A, these elements also have similar properties to each other, the most significant being that they are extremely unreactive, rarely forming compounds. The elements in this group are also gases at room temperature. And lastly, the elements with unknown chemical properties. They exist at the far reaches of the periodic table, specifically among the super heavy elements. Yes, some information exists for these elements, but their complete chemical behavior remains a mystery. Some of them are flerovium, moscovium, livermorium, tennessine, and manganese.
Since we now know the history of the creator of the periodic table, how the elements are organized and the different groups and their properties, let's unveil the information hidden within each of elements group.
Let's take a closer look at an individual element square up on the table. Here's what you'll typically find atomic number, which is a unique identifier as it represents the number of protons in its nucleus symbol, which is a sort of abbreviation for the element, name of element, and relative atomic mass, also known atomic weight, which is defined as the weight gram.
With all this knowledge, you can use the periodic table to predict some of an element's properties. Then let's now master the table. Let's apply what Steven has discussed to what we will typically find in an individual element, square on the table. Let's try it on the third element in the periodic table. So the third element in the periodic table is a chemical element with the atomic number 3 and symbol Li. Lithium is the name of the element. And 6.941 is its relative atomic mass or atomic weight. Since we discussed the periods and groups, let's also identify lithium's placement in the periodic table. If we look at the periodic table, we can see that lithium belongs to period 2 in the alkali metals group for the reason that lithium has 2 electrons in its outer shell and is placed in group 1A, meaning it has 1 valence electron. As I show you the steps, can you now do it on your own? Grab your periodic table as we show you a picture of an individual element square, and you will try to identify its atomic number, symbol, name of the element, and relative atomic mass or atomic weight.
The periodic table is a map of the universe that surrounds us, not merely a simple chart. We can anticipate how elements will behave, comprehend the materials we use on a daily basis, and even explore the possibility of making new discoveries by understanding its information.
Do you now feel curious? How about breaking through all of the individual element information? I promise that it is enjoyable. We appreciate you coming along on this first journey of the periodic table with us. Please feel free to ask any questions in the comment section below. Also, don't forget to like and subscribe for more chemical journey.